And the other thing is inheritance and separate compilation. This is something we use in grSim as well, in our own version. So we made a robot and goalie class to help us organize the code, because all the detection data is giving us is a bunch of robots and their positions. There's no labels to them. So the first one of the things we did was that we made our own classes to distinguish them and then to send orders to these positions efficiently. So here's the two classes. All right, so we made a simple robot and goalie class. Goalie is a subclass of it's a derived class of robot. So a goalie can also be a robot. And then we put some methods in here that we can call, for example, updates, which is being passed within the one of the detection data that we get from messages. The robot will go in this message, find this ID, gets the new coordinates of this, gets its new coordinates, and then handles all the stuff itself. And we have a few functions inside. For example, there's a path to. We'll find a path to this target location, which is one of the path hunting that you see in the obstacle with avoidance was all built in here. And yeah, the format. So in C++, when you do separate compilation, it's different from if you come from a C# background. It's going to be quite different, because to do this properly in C++, you basically have to make a template file, which is all the forward definitions of your methods and private variables, but absolutely no definition. Did I say that right? I guess. So it has all the templates, but absolutely no definition. And all the definition has to be defined in a separate file with the same name, but in a .cc or cpp extension. And this has all the implementations of all the functions here. Then you can, in your own code, for example, this one, I'm including robot.h at the top. And then this will get access to all the functions listed in robot.h. And then this is a template I'll pass around and compile within each of the file that needs robot to be part of the program. And the definition is actually involved here in robot.cpp. But how do you compile it? Usually, you have to compile each program separately. For example, I'll have to compile do G++, which is the C++ compiler. I think it's -C. And then with the, for example, robot.cpp, I'll get a robot.o file, which is an object file. And then at the end, I have files and a main object file. I have to link them all together with something like this. Or I can just do a make or qmake, for example. With our code here for the coach, our binary is called server and the port number that we chose to it. So this .pro file, which is the file that qmake takes. The qmake takes. So target is the name for the binary that we're going to generate, and sources are all the different source files that you want to be linked together at the end, and including some of the libraries that you want to include. So once you run qmake, if you go into this, oh sorry, this is still running. So if you want to go into this folder and you type qmake, you'll generate a make file for you, which is here. And then this is generated from the file you had, the .pro file you had. And then you see this is more complicated. You can sort of see why you don't want to do this by yourself. qmake handles it for you. And then once you have this file, you can just type make, and then you'll make this entire binary in the format you basically told it to. And then you'll make this application. For example, if I'm in here and I type qmake, which there should be no changes whatsoever. And I spelled that wrong because I capitalized it. And I type make, there should be no changes because I didn't make any changes to my code. Make detected no difference in the object file that was already there, so it didn't do anything. But if I change something, it will recompile every single thing that was changed and link them together to make it work. So putting it all together, this is part where I'll show you some of how to get, for example, the beginning of our video and our actual simulator. So this is the, we don't want this because this is modified. Okay, this is our coach client, which actually sends commands to the simulation server. So if you want to achieve a 1 versus 1, we don't need all these the extra goalie from blue side, and we probably do not need the blue attacker bot, right? Actually, we need blue bot. We don't need a yellow because I commented out the yellow. There we go. So now if we go into here and type make, it should make me the new server, which I'll run through while grind. See, now it's waiting for a connection. So now I'll run the simulation server on grSim. It should make it a 1 versus 1 game like we did in the video above. So the robot will find a straight line to the goal and shoots a ball to it. It's pretty straightforward. And I guess I should show the co-op code. It's much better. So we have, in our implementation, we have an array of robots and of robot pointers, so we can cast them to be goalie whenever we wanted to. So afterwards, we define shooter bots and passer bots. So basically, the attacker and an assist. So now, if I uncomment the code for the blue shooter bot, it should work. Blue bot for I think that was it. Let's try making this. We have a co-op. Yep. So the robot should make a pass, and then the other robot should try to score, or whoever is closer to the goal. So that's part of the co-op code that we did. That's it. Right. Yeah, and now I won't bother showing the 3-3, just simply putting more robots on either side. So improvement for this would be like, as I said before, we should listen to the data output from grSim without actually hacking it and making our own client to send out to a different port. We should listen to the port that was that originally had, and we should make a strategy class for making decisions on a broader scale instead of having the robot decide where it should go and what it should do. And we have lower level function in the robot. So basically just simply move, shoot, rotate, and the strategy will handle what command to send to each robot. Much like our model for the real robots. And the other idea is that we should have a temporary instruction buffer in the robot class, so you'll carry out the instruction until it gets a new instruction. This is to handle maybe delays in the program and communication. And also, we took grSim from team Personal Robotics, so we should give them credit for making this open source. It's all thanks to them that made this possible. And that's it.